Okay, right, so this is the second video for today. We'll see how much we get to do here. It sounds confusing, it sounds difficult. Implicit differentiation actually is, okay? So what is implicit? Well, we've got implicit and explicit types of function. Not types of function, but represent. I don't know what's the word to say, but normally we have y equal 2x plus 1. That could be a function. We will call that explicit representation of the function. What does it mean? You've got the y on the one side and all the x's and stuff on the other side. That's the way functions should be, right? Okay? On the other hand, we also have implicit. I don't know really what these words mean, but it means that it's a bit, I call it a naughty function. Okay? It's just not nice. I mean, I don't know what the y is equal to. It's just all shoved in together. Right? Now, everything we've done so far helps us to find the derivative of explicit function. I've got the y equals something, and then I do whatever I need to do to that something. But what happens if I've told that I've got the y's and the x mixed together? So the one way of doing it is to turn this to the explicit form. Form is probably the right word. This is the explicit form of y, this is an implicit form. So how can we find the explicit form of y? I'm just doing a bit of algebra. Exactly. So I'll start by saying, okay, y squared equals 4 minus x squared. And then I'll do one more. I'll take a square root. Y equals square root 4x minus x squared. Maybe there's plus minus. There's an issue here. Yeah. Okay? And now I can find, if I want, because initially what am I working for? It's not just, it's differentiation. Now I can find out the derivative. Let's do it. Let's do it. Okay, so I can write that in even a nicer way. I can say 4 minus x squared power half. Okay? Let's find out the derivative. Again, it's a use of the chain rule here. Chain rule is so important. It really is important. So what's the derivative of y? A half times
4 minus x squared.
Fantastic. To the power minus half. So that's the derivative of the outer function, and the derivative of the inner function. That's the inner function. What will be the derivative? Minus 2x. Okay, so you've got 2x, but you've got that minus here. Okay, let's write it in a nicer form. It's going to be minus 2 divided by 2, so that cancels out. So I've got minus x divided by square root of 4 minus x squared. I think it's something like that.
Yeah.
Okay? All right. Now I'm going to show you how you can find that in an easy way. Okay? Because obviously here, I had to do something here, a bit of algebra to get y on the other side. Sometimes it's going to be really difficult, maybe even impossible. Sometimes you can't go find the explicit form. We went from the implicit to the explicit. But sometimes it's actually not going to be possible or just too difficult. You can do the derivative straight away. Check this out. What we're doing on both sides, I'll write it here, we're going to do d to dx. Okay, so this is where it's a bit confusing. Normally, when what we do to one side of the equation, we must do to the other side. But when we say what we do, we mean we multiply by 2, we square root it, we divide it by 5, we do something, but actually we can find the derivative of each side. In this case, the derivative with respect to x. What's the derivative of x squared with respect to x?
2x.
It's 2x, you're right. So I'm going to have 2x. Let's leave that for a second, that's the harder bit. What's the derivative of 4 with respect to x? Remember?
0.
It's 0. Like we said, if you find the derivative of any number, it's always 0. So I just need to find the derivative of y squared. Let's write it down here. The derivative of y squared with respect to x. We've never done that. Well, we're doing it, but we didn't write it like this.
So that vertical line, is that part of the layout?
No, it's like I'm showing to you like I'm doing this, the derivative with respect of x to this side and to that. So I the way I do it, I put a line that tells me I'm doing it to both sides of the equation. That's how I was kind of shown.
Okay.
Yeah? So what's the derivative of y squared respect to x. We got to use the chain rule here again. We've got a function of a function. I mean, y, I don't know even what y is. Maybe I should have told you in the beginning. I don't know what y is. I'm trying to find out what it is. But I know it's a function of x. Okay?
Yeah.
But now I'm not looking for the derivative of y with respect to x. I'm looking for the derivative of y squared. So I'm just going to show you that, and hopefully that makes sense. What you got to say? Okay, it's 2y. Give myself more space. 2y times dy to dx.
So you're making y squared the subject of the formula.
Yeah, I'm doing the derivative of what that is. Let me maybe write it here. What's the derivative of that with respect to x? Well, the chain rule tells me, okay, basically do the derivative of the big function with respect to the small function. So it will be 2y, and then time it by the derivative of y with respect to x, which I don't know what it is. I'm just going to write it, dy to dx. Okay, we're going to do examples, so don't worry too much if at this point you're a bit confused. Okay, now I've just put it there, so I'll erase that. Okay, I'm stressing to you guys, I don't know what y is. I don't know what y is, but I just have another equation for the derivative of y and x. Now I can solve that. It's pretty easy. Check this out. Okay, I'm just going to move the 2x to the other side, so I'm going to have 2x. No? To the other side. 2y dy divided by dx equal minus 2x. Now I'm going to get rid of, because I just want to remind you, what are we actually after? We're after the derivative of y. That's what we're after. We're trying to solve. What I'm trying to do now is to solve the derivative of y. Okay? The derivative of y with respect to x. Now I'm going to divide by 2y. So dy to dx equal minus 2x divided by 2y. Okay, that means dy to dx equal minus x over y. And then I got an answer, which obviously is not the same as this answer, because here I still don't know what y is. But then it depends what they're actually asking me. So I'm just going to pause here and again to look at what they actually asked me here. Okay, so at this point, I got a bit confused, okay? Because what we actually get, we're finding the derivative. The derivative of y with respect to x is minus x plus y. But we don't know what y is, okay? So at this point, you might say this is a nonsense method. Why would I use that? Here, I've got, I can tell you what's the derivative of y, okay? It's minus x over square root 4 minus x squared. So if I just ask you what's the derivative, then that's rubbish. I can't use that because I don't know what y is. But when will it help me? It will help me when I have questions like that. I just want to see that you can see them in the camera. Yeah. So what the question was really, and I probably should have said that in the beginning, is they didn't actually want me to find the derivative. They want me to find out the gradient of a slope, or of the slope of a tangent to the line x squared plus y squared equal 4 at a specific point, square root 3 and 1. Let's try and figure out what they mean, okay? Let's try and figure it out. First of all, this little function, x squared plus y squared equal 4. What does it describe?
Circle.
It's a circle, isn't it? It's a circle. The center is? The center is the origin, and the radius is 2. You're right, okay? So this is the curve x squared plus y squared equal 4. Okay? Now, what are they telling me? They're telling me, look, somewhere along this circle, I've got that point, square root 3 and 1. Okay? So x is square root 3, y is equal 1. I've got this point, square root 3, 1. Okay? Now, at that point, okay, by the way, let's try and see it works. If I put square root 3 squared, that will be 3, plus 1 squared is 4. So it works. It is on that line. Now they're telling me at that point there is a tangent. There's a tangent. Okay, you know what tangent is, right? Now they tell me I don't mind what that tangent is. What I want to know is what the gradient of that tangent is. What's the gradient?
They don't want the formula.
They don't want the formula. That will come next time, not today. Okay? But they just want the tangent here. Okay? So what could I do? One way of doing it, the maybe more straightforward way, but more difficult, is what we did here. First of all, convert the implicit form into explicit form. Okay? Then do the derivative. And then all you got to do is substitute. Okay? You put what is x equal to? Square root 3. You put it there and you get something. I'm telling you guys, don't have to work too hard. Okay? I know here it's kind of the same amount, but later on, trust me guys, this method is much better. What you can do now is just find what's the dy to dx in terms of x and y. And now, and this, until now, it didn't help us, but because I don't know what x and what y is. But now I know. They tell me in a specific point. So what is the x? The x is square root 3 minus square root 3. What is the y? The y is 1. So I get minus square root 3. So I know, with very little work here, that the gradient here is square root 3, minus square root 3. I'm just going to pause here and check something. Okay, so I just want to show you, to close here, that this value, minus square root 3, okay, which is the value of the gradient, okay, which is the value of the gradient of the tangent of the line here, of this curve, I want to show you that the same thing you'll get if you go on this way, okay? So if I use this method, again, I'm substituting square root 3 and 1, so x is square root 3, okay? And then I do 4 minus the square of square root 3 is obviously 3, okay? So again, I'm getting minus square root 3, okay? I'm getting the same thing, okay? Now, let's see if I've got any more examples. Let's just do one more example. Okay, so as a final example, I've got another curve. Okay, it's a curve. Very difficult curve. Okay? The y is a very naughty curve. The y is all over the place, all mixed together. I challenge you to try and find what y is in terms of x. So very difficult. Okay? What we want to find out the gradient, the value of the gradient of the curve, or, the curve will be something like this, let's say, this is y. And at the specific point, minus 2, 1, I want to find out the gradient, okay? The gradient of this. What we're going to do next time, like Rachel anticipated, we're going to find the function of the tangent. But we'll do that next time. So for now, I just need the gradient. How do I do that? Let's use, this is the explicit form, not the explicit, implicit. We'll just do the derivative of that, okay? So I'm doing the derivative of this thing, okay? So now, okay, so that's a little bit difficult, okay? Let's write that. I've got the function xy cubed plus 3x squared equal xy plus 12. Let's write them one by one. What will be the derivative of xy cubed to dx? We've got a product function here, isn't it? So you're really using everything we learned today. We've got x times y cubed. What's the derivative of that? Well, it tells us we do the derivative of the x, which is 1, time the function itself, the second function, which is y cubed, and maybe I'll write it down here for you, okay? The derivative of f is going to be the derivative of g times h plus g times the derivative of h, okay? So we did the derivative of x, which is 1 times y cubed, plus now we need to do x times the derivative of y cubed. What is the derivative of y cubed? Now we need to use the chain rule. What will be the derivative of y cubed? Okay, that's the tricky bit. This is the thing you're not so used to. What's the derivative of y cubed with respect to x? Okay? This is where I think is a little bit tricky. So we use the chain rule, right? We've got the small babushka and the big babushka. So we're going to do 3y to the power of 2, and time it by the derivative of the inner babushka, which is just y, dy to dx. I don't know what it is. It's a bit tricky, eh? The thing is, it's just a bit more abstract, okay? is 3y squared times the derivative of y. Normally I get something, but now I just don't know what it is, so I call it dy to dx. Remember, this is actually what we're trying to find eventually. Okay, I will do more practice next time. Okay, so I need to time x by 3y squared times dy to dx. That's just this bit. Okay, that's just this bit. Okay, now, so let me write that down. We're doing the derivative of that with respect to x, of this whole thing. So that's actually the hardest one. The rest will be a bit easier. So I'm going to copy that. It's going to be y cubed. If you don't mind, I drop that one. We don't need that one. Plus 3xy squared. I just arranged them a little bit. Times dy to dx. Dy to dx. Okay. On the other side, what happens when you do derivative of 12?
What happened to x squared, 3x squared?
Am I missed something?
In the top equation, it's 3x squared.
Let me just pause for a second. Okay, so Rachel realized we almost got rid of the 3x squared, which is not good. Okay, this is just the derivative of that. Okay, what's the derivative of 3x squared? That's easy. There's no y's. As long as there's no y's, then it's pretty easy. What's the derivative of 3x squared?
6x.
That's it. Okay, the derivative of the 12 is easy. What's the derivative of 12?
No. 0.
0. Okay, let's find the derivative of xy with respect to x. And it's another. Every time x and y's are mixed, it's a bit of a headache. Again, it's a product rule, x times y. So I've got to do the derivative of x with respect to x. What is dx to dx? Derivative of x with respect to x. Okay, if let's say y was equal to x, what is dy to dx? How do you do the derivative of x? Okay, it's just 1. Okay, so the x, when you do the derivative, is just 1. 1 times y plus x, that's the product rule again, tells me, times the derivative of y. What's the derivative of y with respect to x? I don't know what it is, so I'll call it dy to dx. Okay, this is what confused you here, guys, because we're trying to find dy to dx, but we don't know what it is, so we just call it dy to dx. Okay, we do that a lot in math. So if we don't know something, we just call it what it is, dy to dx. Okay, I'm going to write that instead of here, so I'm going to say y, again I'm dropping the 1, plus x dy to dx. Yeah, I can definitely see we're going to do more practice on Thursday. I'll send you more videos with maybe smaller bits of that. Okay, now what am I trying to actually do? What I'm trying to do is solve for dy to dx. I don't care about the x and the y's. They must go to the other side. I want to know what dy to dx is. So I'm going to move the y to this side, move that term to that side. So I'm going to have, I'll write from here, x dy to dx minus 3xy squared dy to dx. I just shift that one over to here. Y I want to chuck onto the other side. I'm going to have y cubed minus y plus 6x. Okay? Now, how would I get rid of these things? What should I do? Look at this. This is kind of like algebra. You never had derivatives stuck in your equation. I want to find out what dy, the end product is dy to dx. So that's got to be equal to something with x and y. So how would I do that? What do I need to do here? Missing a word. Let's start with f. Exactly, factorize. Okay. So I'm going to write dy to dx, x minus 3xy squared. Okay, I can actually take even x out if I want, but no need. And then that's equal to y cubed minus y plus 6x. And now I'll shove it down. I'll divide both sides by this. So I get dy to dx is y cubed minus y plus 6x divided by x minus 3xy squared. Okay? And now our time is kind of up. So I'll let you do the rest bit at home. Okay? Remember, we're not really interested, what we're interested in is the value of that function. Where? I need to find out where. Okay? It's a specific point at minus 2 and 1. Let's finish it up. So everywhere there's x, I'm putting minus 2. Everywhere there's y, I'm putting 1. So 1 cubed minus 1 plus 6 times minus 2 divided by minus 2 minus 3 times minus 2. I'm hoping I'm not making any mistakes here. Time, what is y? 1 squared. I just substituted in that. I've got, basically what I've got here is a function. I created a function, an explicit function of dy to dx. Not y. Actually, I don't care about the y. Why I'm interested in finding what dy to dx is. And then I substitute the x and the y's. And I get 1 minus 1 is 0. It's looking like it's minus 12 divided by minus 6, 4 maybe? 4? 6 minus 2? Minus 3? Maybe? Okay?
At least it's not like a weird decimal.
Yeah.
So
let's see if they got the same. I'm scared. Yeah, they got minus 3. Okay? So just a preview of next lesson. I'm not going to do it now, don't worry. What we're going to try and find out, we found that the derivative is minus 3. That's your m. That's your m. The gradient of the curve and the tangent to the curve at that point. Next time we're going to try and find out the equation of the tangent. Okay? But we will practice more because this is the hard bit. I know this is the hard bit when you're trying to work out derivative of things like that. That's the hard bit. We'll practice more of that. Okay? Brilliant. Okay.